All right, in these problems, we're trying to determine whether or not we have a valid definition. So for example, I have the definition on here: an obtuse angle's measure is less than 90 degrees, 180 degrees. And in order to determine whether that's a valid definition, which I assume most of us know that that one is not, but we have to rewrite it as a biconditional statement. All right, so we're going to rewrite that as a biconditional statement. The biconditional statement would be: an angle is obtuse if and only if it is less than 180 degrees. All right, and so if that biconditional statement is a valid statement, then so was the definition we began with. Okay, assuming those two are equivalent. So to figure out whether the biconditional statement is correct or not, we need to break it down into its conditional statement and its converse statement. And if both of those statements are valid, then the biconditional statement was also valid. So let's look at the first one here. If an angle is obtuse, then it is less than 180 degrees. That is true, okay? It has to be less than 180 degrees. Let me do that here. So that one is true. Now, the converse of my original, or of the biconditional or original conditional statement is: if an angle is less than 180 degrees, it is obtuse. Now that is not true. What's our counterexample here? Well, let's go with 89 degrees. That's less than 180, but it is not an obtuse angle. So that means that our definition, our biconditional statement, was not valid because those two were not. And of course, my definition at the very beginning was not valid either. So we have to look at the biconditional statement version of the definition. If the biconditional statement, if it's conditional statement and converse that combine to make it, if either one of those is false, then everything else was false up above there, biconditional and definition. Okay, even if one of them, say the conditional statement in this case, was true, okay, if one of the two conditional or the converse fail, then the definition fails. All right, let's look at one more example here real quick. So this one, definition: a right angle's measure is 90 degrees. The biconditional statement would be: an angle is a right angle if and only if its measure is 90 degrees. That biconditional breaks down into the conditional statement: if an angle is right, then its measure is 90 degrees. And it also breaks down into the converse of that conditional statement: if an angle's measure is 90 degrees, then it's a right angle. Now, okay, so we're trying to prove or disprove that biconditional statement, that biconditional definition. Okay, so we need to make sure that both the biconditional and the conditional or converse are true. If an angle is right, then it measures 90 degrees. That is a true statement. All right angles must equal 90 degrees. If an angle's measure is 90 degrees, then it's a right angle. And that is also true. If it's 90 degrees, it has to be a right angle. Okay, which means since both the conditional and the converse were true, guess what? Yep, that biconditional definition is also true, which means our definition is good. All right, if this still doesn't make sense, these are difficult. Okay, please ask your teacher for help. Please, please, please. All right, good luck.